Hello friends, welcome back to the bench. Thank you very much for joining me. We have two patients today. These are B2600i. Although they were advertised, the customer said that these are B2600, not I, right? The 2600s without injectors, they actually use the carburetor, what is it called, the feedback loop carburetor. So it still has solenoids inside, so the driving circuit looks similar. So I thought this one was controlling the carburetor. But after further research and stuff, I discovered that this is a very rare 1989 B2600i. It does have injectors, but as you can see, it looks very much different than the 91 and 91 to 93 version and even 90 version, right? So we have an MCU over here. This is the I/O controller. This one, I have no idea what it is. And this one, also no idea what it is. We have two injector lines over here, the exact same design that we have on 91. We have two injector transistors, we have two control transistors, the same idea. We have a pull-up, the transistors are always open, and these two control transistors over here, I'll show you a close-up image in a second. These two little ones, they control, they essentially close the output transistors, right? And that's how we control the injection. The ignition is also controlled the same way by this little guy over here, and we have only one transistor for the ignition, so ignition is pretty much sparking all the time. Now, what do we know about these two? So I already spent like hours emailing back and forth with the customer, getting the full picture of what's going on and what has been done. So this one is faulty, but it partially works. So one injector line is always open, it's flooding the engine, but the other one is working. So two injectors are working on this one, two injectors are not working. So the car technically starts and it even runs, but you know, on two cylinders. The other one, on the other hand, this one doesn't run at all. It doesn't start, but if you spray starting liquid into the collector, it starts because it cranks and everything. If you start cranking, the cell LED or the light turns off. So we know that we have a signal coming from the distributor. Because if you don't have a signal coming from the distributor, the injectors will never open because the ECM doesn't know when to open them. And we need two signals. One is for the RPM. So this is a relatively high frequency signal that is just indicating that the engine is cranking. And we have position signal that tells the ECM when the piston is in the position in the compression or after the compression. So that's when we no, not after the compression, when it's at the lowest position. So that's when we inject fuel, then we compress, ignition, and well, spark, ignition, and the exhaust. So we try to eliminate the distributor. I think we reliably eliminated the distributor from being at fault over here. And that's both based on the visual inspection and how the ECMs are behaving. So first, let's grab the one that does start, but it's messing up with the two injectors, right? So let's connect it on the bench and do some measurements. So the first thing that we want to check is Q18 and 19. That's our injection. So first, let's switch to ohms. Direction doesn't really matter. So first, we want to confirm that emitters are on the ground, right? So you want to see 0 over here. We have 100 some milliohms. That's the resistance of wires and the probes and stuff. So emitters are good. Now collectors should be open, right? Well, we have some mega ohms, right? But collectors should be open, like mega ohms and rising. And the bases, well, on the base we just don't want to see the short. 600 ohms is fine, and 700 ohms, that's fine. So we know these are not shorted, right? Now, as you can see, we don't see any corrosion over here, so we don't have to check continuity, right? So we're gonna skip the continuity test. We're gonna jump right into testing the actual injection. Now, the easiest way to check if we have any faults is check the pull-ups and check the control transistor. So these two transistors are controlling these two transistors. So these are always open, they are pulled up, and these two are disabling them, right? So first, let's switch to the voltage, DC. The red probe goes to the VCC, the power, 12 volts, coming from the power supply. Let's turn on, confirm that we're grabbing roughly 200 milliamps. That means we don't have any shorts or anything. Everything should be fine there. Then the injectors are on these two lines, this one and this one, right? So if we have VCC over here and let's see, it's dropping, right, to 6 volts, 5 volts, and so on. So it's bad, right? And on this one, we have 11.4. So essentially our supply voltage. So this is fine. The injector is closed. So this injector line is okay because it controls two injectors. This injector line is not. We have the voltage is dropping, right? Which means, so now let's switch the black probe to ground and red probe to measure. So which one is it? Let's check the base. The bases should be 0. Base is 1.22 volts, so that's bad. And this one, it doesn't have to be exact 0. We have 60 millivolts, so that's fine. The transistor is closed, right? But this one is not closed, right? This one is open. 122 volts on the gate, or the base. So let's check our control transistors. So this one has 700 millivolts on it, and this one has 10 millivolts on the base. So 700 millivolts, 0.7 volt on this one. That means that this transistor is open, right? Because the base is also a diode, right? So when we're pushing I did a video on the transistors, but the big takeaway, transistors control current, not voltage. But you can use them as voltage regulators, sure. So don't look at the voltage like you expect to have 5 volts over here, right? And that means that the transistor is open. No, you're gonna, in MOSFETs, yeah, with MOSFETs that is the case, because they're voltage controlled. These are current controlled. So our voltage is relatively low over here, because the transistor is open and the current is flowing from the base to the emitter, right? Emitters are on the ground. Now this is the Japanese transistor, so it goes base, collector, emitter, not like the European when it goes base, collector, emitter, right? So emitter is on the left. And you can tell that it's on the ground, right? They're connected. These two are connected together. So these are our bases. And this one has essentially nothing, 9 millivolts, right? So how does it work? We have two resistors, right? So this resistor supplies the top one, so we have 700 millivolts. And this one supplies the bottom one, 10 millivolts. Not enough, right? These are pull-ups, so we got 5 volts over here. Oh, Do we not have... Oh no, these are pull downs, not pull ups. This is pulled down. Right, because the pull ups are over here on the base, right? Which right now, you know, that's why we have which one was it? This one. That's why we have 1.2 volts on the base of this one, because it's pulled up. It's not being pulled to ground by this transistor, right? So we have no voltage over here, and this is controlled. It's hard to see, but the trace is going over here to this transistor, to this resistor. Yeah, from this one. Well, this one is working, right? It goes through this transistor, from this resistor, and this is the control side coming from the control unit, right? And we have 5 volts over here. The other one, this one, we should have 5 volts over here, but we have no 5 volts over here. So indeed, this one is not closing, so this transistor remains open. So now, where is this signal coming from? Right? This signal is coming from this chip. This is the I/O chip. So this stands in between the transistors and the MCU, right? Which is a great thing, because on 91 version, that signal comes directly from the MCU. This one, instead of controlling it directly through the resistors, it uses this little chip. It's a specialized chip, so you know the replacement is not possible without the donor board, right? You can buy this chip. Now we can trace it directly. So it's this one and this one, right? And let's see if there's no broken traces or anything like that. But the ECM looks pretty good. There's no corrosion or anything. And let's go here. I thought it was going directly to the this thing. Let me check again. These two guys. So the one that is not working, 10 millivolts and 5 volts here. So this one's good. This one is not working. I can't see which trace it is because I made a little mess over here. Let's clean it up. Okay, it's here, this one here, and we go directly to this pin, right? And we have no voltage here, and this is the other one. Yeah, this one has 4 volts, this one doesn't, right? Now some people might tell you that it is possible to just bridge them together, right? If one line is not working, and that will work, but it strictly depends on the engine, depending on how it is in sync. On this particular engine, that's not gonna work. You would have to, yeah, because the way it's synchronized, it's the injector is just gonna open during the exhaust cycle instead of intake. So this chip most likely is faulty, because it's very unlikely for the MCU to be shorted or the MCU output to be shorted if we have a chip in between. So most likely this is going to be our culprit. Now we can check the continuity. Let's just for the sake of confirming everything. So from this, yeah. So continuity is there, so the trace is there, because broken trace would explain that, right? This would be an easy repair if this was a broken trace. But there's no broken traces, so our problem is in this chip. And it's not a problem of the whole chip is not working, it's just this specific output. And there's nothing else on that route, on this trace, so we know it's not like something else is grabbing all that power, right? Grabbing the current. It's got to be inside the chip. Now again, it could be if we had a pinout and stuff, we could check, because essentially what this chip is responsible for is just detect the signal from the MCU, right? One of these lines over here, or maybe even from this guy, who knows? And this basically just provides an output stage to control the transistors for the output stage transistors. Now, let's switch to voltage, and let's just confirm all the voltages. Because if now this is not the case over here, because we have only problem on one injector line. But if you have no injection at all, a good thing to check is the pull-up for these comes from this. Why is it there? It's a little crooked. It comes from this LDO that produces 10 volts. We have 10 volts, we do. The logic is supplied by this transistor, 5 volts. We have beautiful 5 volts. And the 12 volt rail is okay as well. So the 12 volt rail, I always check on this diode. Right? If there is a problem, if the MCU is completely dead or the ECM is completely dead, then you're not going to have 12 volts over here. So the only thing wrong that appears is this chip, right? So again, we can't replace it because we can't get the chip. However, we have a donor board, right? So let's see if on the donor board we have a similar issue, because if so, then we don't have a part. But if the donor board is okay, then we can just replace that chip. Let's check it this way. So black probe on ground. Let's check the bases. The base is closed and the other base is closed. Okay. So now let's check the control transistors. So we have 700 millivolts here and 700 millivolts here, right? So this is good. And the control signal, the 5 volts here and 5 volts here. With the 89 injector version, it's a hassle to figure out how it works, because they made very few of these and they quickly switched to the other architecture. So even finding a pinout for this ECM is extremely challenging. I don't have it. I have it for 91 version. I have it for the 80s version, but this is a version like in between, right? So there's just not a lot of data that we can find on these. So essentially, pretty much everything that I know about these ECMs is from reverse engineering. I get nothing from the FSMs or whatever. Anyway, the injector lines are okay on this one, right? So we have no problem. So this chip is working fine. So we can take this chip and put it on the other ECM. But what's wrong with this ECM? So since this one has working injectors, how does it behave? So when you put this one in the car, it doesn't start, right? It cranks, but it doesn't start. If you inject or if you spray the starter fluid in the collector, it will start. So we have, what does it confirm? We have a spark. The distributor must be working. I mean, we know the distributor is working somewhat because the CEL flag is going down. If you disconnect the distributor and start cranking, then that light stays on. So that's how we know the distributor is producing signal, at least some signal that is making it to the ECM. However, this one just plainly doesn't turn on injectors, right? So if it starts with starter fluid, that means we have a spark, but the spark is just, this transistor opening and just producing spark. So it's a very simple circuit. It always sparks on all cylinders, right? So the reason it doesn't have an injection at all is that the MCU is not receiving a signal from the distributor. But since we know that the distributor is producing the signal because the other ECM is working on two injectors, this must be a problem of something here. Okay, I guess this is what we're gonna do, because I can't see anything electrically wrong with this one. I also don't see any broken traces or any corrosion or anything like that, because that would be an easy repair, right? Well, sometimes it's not easy, but at least you know what you're working on. Here, you know, I think we thoroughly eliminated the distributor, and we confirmed that this one is indeed no, this one, right, is indeed not is indeed shorted on one injector line. So what I suggest, or at least at the moment, because I'm gonna work on it a little longer, but we're just gonna take the chip off of this one. We're gonna take this chip and we're gonna put it on this one. We're gonna send it back. Well, first we're gonna confirm that we no longer have a shorted injector line. If the injector line short goes away, that was the problem. If the injector line short doesn't go away, then we have to replace this chip, the MCU. Hopefully that's the one, but yeah, usually when they have the actual markings for the engine, right, this is E715, that's usually the MCU, right? But we also have big chip over here, right, and a big chip over here. Definitely this is IC8. It's definitely not the MCU, so it either could be this one or this one, but usually when you have markings like that, that's gonna be the MCU. But it's also not given, it's not 100% for certain, because on some ECMs you have the MCU that is an ECM, and you have an MCU that is a TCM, and sometimes you have 3 MCUs, and one is for the powertrain, one is for transmission, and one is for body control. And sometimes there's even 2 separate EPROMs, so when you want to program it or something like that directly, you have to program 2 chips on one ECM. That's crazy, but yeah, I've seen that on Honda. I think Honda's like that. So I think that's what we're gonna do. On top of that, we're gonna recap everything, right? Replace the caps. We're gonna inspect a little further, give it some cleaning, and give it the brand new conformal coating, so it's nice and shiny, right? Although this one is in a really good condition, both of them. No corrosion, no nothing. But first we have to hear back from the customer if that's what he wants to do, because if not, I can just continue to try to reverse engineer where that signal comes in. Eventually I'll find it. It's just a matter of time. But we don't want to spend too much time on it, because we would technically have to bill for that time, right? So the quicker we can resolve the problem, the better for the customer, the cheaper, right? Alrighty, we're gonna call the customer, we're gonna see what he wants to do, and how much time we have for this, and what the budget is, and all that kind of stuff. And we're gonna revisit the subject. Although replacing that chip is nothing special, so you know, I don't know if that would be interesting to anyone. It's pretty old school electronics over here. Alrighty, thank you guys very much for watching. I do appreciate you, and I shall see you guys in the next one.